In behalf of Group 7, I'm Lana Tabobo and we'll talk about John Dalton and his contributions to the field of science, particularly about chemistry. John Dalton is an English chemist born in Eaglesfield, England on September 6, 1766. But what is John Dalton most famous for? Ancient Greek philosopher Democritus had postulated an abstract theory which states that everything is composed of atoms which are indivisible. But since this idea of atoms lacks evidences that could prove its legibility, this was disregarded in the scientific community. Dalton then used the term atom for his atomic theory, which he developed after performing numerous experiments. His theory postulated that every form of matter is composed of small divisible particles called atoms, and that they can be combined, separated, and rearranged during chemical reactions to form compounds. Dalton based his theory on two laws, the law of conservation of mass and the law of constant composition. The law of conservation of mass states that matter is not created or destroyed in a closed system. That means, if we have a chemical reaction, the amount of each element must be the same in the starting materials and the products. We use the law of conservation of mass every time we balance equations. The other law is the law of constant composition. It states that a pure compound will always have the same proportion of the same elements. For example, table salt. It has a molecular formula of NaCl, which means sodium chloride. It contains the same proportions of the elements sodium and chlorine, no matter how much salt you have or where the salt came from. If we were to combine some sodium metal and chlorine gas, we could make more table salt which will have the same composition. Dalton hypothesized that the law of conservation of mass and the law of definite proportions could be explained using the idea of atoms. He proposed that all matter is made of tiny indivisible particles called atoms, which he imagined as solid, massy, hard, impenetrable, and movable particles. It is important to note that since Dalton did not have the necessary instruments to see or otherwise experiment on individual atoms, he did not have any insight into whether they might have any internal structure. We might visualize Dalton's atom as a piece in a molecular modeling kit, where different elements are spheres of different sizes and colors. While this is a handy model for some applications, we now know that atoms are far from being solid spheres. For example is the compound table salt. Table salt is a combination of two separate elements with unique physical and chemical properties. Sodium is a highly reactive metal, while chlorine is a toxic gas. When they react, the atoms combine in a 1:1 ratio to form white crystals of sodium chloride. But, since atoms are indivisible, they will always combine in simple whole number ratios. Therefore, it would not make sense to write a formula such as Na0.5Cl0.5 because you can't even have half of an atom. Dalton's atomic theory suggests that chemical reactions don't destroy or create atoms. They merely rearrange the atoms. Using the table salt as the example, when sodium combines with chlorine to make salt, both the sodium and chlorine atoms still exist. They simply just rearrange to form a new compound. Following are the postulates of Dalton's atomic theory. All matters are composed of tiny indivisible particles called atoms. All atoms are indivisible, unchangeable, and indestructible. Atoms of different elements may combine with each other in a fixed, simple, whole number ratios to form compound atoms. Atoms of the same element can combine in more than one ratio to form two or more compounds. Atoms of the same element are similar in shape and mass, but differ from the atoms of other elements. The following are the drawbacks of Dalton's atomic theory. Number 1. Atoms can no longer be considered indivisible. Atoms can now be divided into subatomic particles like proton, neutron, and electron. Number 2. Atoms of the same or different types have a strong ability to combine together to form a new group of atoms. And lastly, the discovery of isotopes indicated that all the atoms of the same element are not perfectly identical in all aspects, and atoms of different elements are not different in all aspects as well.
Isotopes are of the same element but different mass.
For example, a deuterium element is an isotope of hydrogen. Since deuterium element has a mass of 2 and a proton of 1, it is an isotope of a stable hydrogen which has only 1 mass and 1 proton. This is Dalton's atomic theory.